Assalamu alaikum and welcome to Cambridge Chemistry with Ms. Sarbat Ahmed. Today I will be solving Chemistry A-Level MCQs paper 1-2 from Feb March to 2021 part 2. Question number 21. How many tertiary alcohols have the molecular formula? So let's draw the different formulas of C6H14. C6H14 so let's draw. This is CH3, CH3, OH, CH2, CH2, CH3. So this is 2-methyl 1 2 3 4 5 2-methyl pentane 2-ol. This is one tertiary alcohol. Now this another possibility: COH, CH2, CH3 and CH2, 3, CH2 and CH3. 1 2 3 4 5 6. So the name of this compound is 3-methyl 1 2 3 pentane 3-ol. So this is another possibility, can be there: CH3, CH2, COH, CH3 and CH3. 1 2 3 4. 2-methyl 3-methyl 2,3-dimethyl butane 2-ol. So there are three possibilities, three different tertiary alcohol can be there. So the correct answer is 3. So this is question number 22. The diagram shows a structure of a bromo compound that may be formed by the reaction of bromine with a hydrocarbon. Which row is correct? So BR it could be the substitution reaction because two bromine atoms are not attached with the two adjacent carbon atom. So it could be substitution reaction. So there are two substitution reaction. So because two bromine atoms are attached on two different atoms, so it could be the not nucleophilic, it could be the free radical. So substitution is correct, and free radical, not nucleophilic. Addition nucleophilic can be Br, 1 Br or Hs can be attached, but over here 2 Br on different carbon atoms which are not adjacent with each other, so that's why it could be free radical mechanism. So the type of reaction is substitution and the mechanism is free radical. So answer D is correct. Part of the structure of Strobilurin is shown. R and R dash are inert groups. R and R dash are inert group. Strobilurin is formed with aqueous sulfuric acid producing compound X. Compound X is then treated with hydrogen in the presence of nickel catalyst. So when it reacts with aqueous sulfuric acid, so this is an ester group, so it could be OH, and this is the R dash double bond, double bond, double bond, and R. So plus CH3 OH. So compound X is then treated with hydrogen in the presence of nickel catalyst producing hydrogen compound Y. So this is addition of hydrogen. This is addition reaction over here, and addition reaction means that all unsaturated hydrocarbons are converted into saturated. So all alkenes, all double bonds are broken down and saturated alkanes are formed. So what could be the structure of Y, compound Y? So producing compound Y. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. R dash double bond O OH. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So over here CH3. So all double bonds are broken down and converted into, and this could be A. A is correct answer. Which compounds produces a ketone when refluxed with an acidified solution of potassium dichromate? Which compounds produces a ketone? Secondary alcohol is converted into ketone, while primary alcohol is converted into aldehyde, and tertiary alcohol cannot oxidized. So let's check the options. Pentane to 1-ol. So this is primary alcohol. This is primary alcohol. It is converted into aldehyde or carboxylic acid, refluxed with an acidified solution of potassium dichromate. So oxidized into aldehydes are carboxylic acid because it is primary alcohol. 2-methyl butane 1-ol. This is incorrect. Which compound produces a ketone? 2-methyl butane 1-ol. This is B. Let's check. Butane 1-ol. 2-methyl CH3. So it is also converted into aldehyde or ketone. Aldehyde. This is converted into aldehyde. So this is also incorrect. 2-methyl C part is 2-methyl butane 2-ol. OH 2-methyl CH3 CH2 CH3. So this is converted into ketone. CH3 CH2 C double bond O CH3 and CH3. This could be 3-methyl butane 2-ol. This is tertiary alcohol, so this is tertiary alcohol, cannot oxidize. So this is also incorrect. 3-methyl butane 2-ol. OH CH3. This compound will be converted into ketone. H. So this is converted into, because this is secondary alcohol, so it is converted into ketone. CH3. So D is correct option. Now question number 25. Dibromopentenes can undergo double elimination reaction to produce hydrocarbons. So this is the dibromopentane. It means double elimination mean 2 hydrogen and 2 bromine atoms are eliminated. So which isomer produces only one hydrocarbon product? 1,5-dibromopentane. 1 2 3 4 5 1 5. Br, Br. So our HBr, HBr, two HBrs. Two NABR and two H2 are formed. So what happened? C double bond C H CH2 1 2 3 4 CH double bond CH2. So this is the only one product plus 2 NABR plus 2 water molecule. So 2 Brs and 2 H2s when react with sodium hydroxide. So this could be correct. Now look at 1,4 dibromopentane. 1 2 3 4 5 1 4. This is 1 4. We are mean two different products can be formed. Double bonds over here, H H. Two products could be formed. C double bond C C 1 2 1 2 3 4 5. So C this is the, and this is another product, C double bond. So this is another product. So this is incorrect. 2 3 So let's check this. 2 3 C part 2 3 dibromopentane 1 2 3 4 5 2 3 dibrom Br two products are formed. C double bond and 1 2 and there is another product. also incorrect. And D also, 2,4-dibromopentane. 1, 2, 3, 4, 5, 2, 4, 2, 3, 4, 1, 2, 3 and 4. So also two products could be found. Sorry. Two, 4. Beer 3 and 4. C double bond. So also incorrect. So A option is correct. The diagram shows the formation of compound Y from compound X in a chemical reaction. R1 and R2 are alkyl groups. X plus HCN, KCN, R1, R2, OHCN. Which row about this reaction is correct? Mechanism, identify the mechanism, and so CN, when CN is added, this is nucleophile. So nucleophile addition reaction. So let's check. R, this is R1, C double bond O, and R2. So this is nucleophilic addition, HCN. So partial negative, partial positive, and this is R1, COH, R2 and CN. So this could be ketone. So nucleophile CN is nucleophile, so nucleophilic addition, and not aldehydes. It is C option is correct, nucleophilic addition and ketones. Because CN is nucleophile, so cannot be electrophile, so this is incorrect. This is also incorrect. And this is secondary alcohol, R1C, second on second carbon OH is attached, so it is secondary alcohol, so that's why it is produced from the ketones. So ketone is correct and nucleophilic addition is correct. In this question, you can assume that H1 and H3 have the same chemical properties. A sample of ethanol contains only one isotope of hydrogen, H1. It is reduced to compounds EC2H6O in a nucleophilic addition using the NaBH4 all the hydrogen forms atoms in the NaBH4 are H3 isotopes. Okay, it is reduced to compound Z. Compound Z is, this is ethanol, this is ethanol containing only H1, and it is converted into ethanol, reduced into ethanol. So it means C double bond O it is reduced to C2H6, mean NaBH4, it's one isotope. O so this is again oxidized. Three, and CH1, H3 and OH1. So this is oxidized to CH3 and plus water. So this is converted into, when it is oxidized, C 3 and C double bond O and H3 plus H2O. OH. So both ethanol and which statement about the final mixture of product is correct? So both ethanol and water contain H3O. This could be correct. Ethanol is the only product contain H3 atoms. This is incorrect. Neither ethanol nor water contain H3 atoms. Water is the only product contain H3. This is also incorrect. So A option is correct. Ethanedic acid has the formula HO2C CO2H. What is the formula of aluminium? ethane dioate, aluminium Al(C2O4), HO2, HO2CCO2H. When react with aluminium, what is the formula of aluminium? So this can be removed, this can be removed. So AlO2 CCO2 thrice, because aluminum carrying 3 plus charge. So this is this option, Al2O2 is correct. 29. Which reaction gives a butanoic acid as one of its product? Acid hydrolysis of butyl ethanoate, A. Butyl ethanoate. So this is butyl ethanoate. This is ethanoic acid, not butanoic acid. So this is butanol plus ethanoic acid. So this is incorrect. Or which gives butanoic acid as only one product? So acid hydrolysis is correct, but this is incorrect. Alkaline hydrolysis incorrect. Butyl ethanoate, this is also butyl, butanol. CH3, CH2, 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 OH plus ethanoic acid, CH3COH. So acid hydrolysis is correct. This is also incorrect. Ethyl butanate, this could be correct, because ethyl butanate is converted into butanic acid and ethanol, like ethyl butanoate, CH3 CH2 CH2 C double bond O and CH2 CH3. So this could be alcohol, CH2 CH3OH, and because acid hydrolysis is there, so other product is butanoic acid, CH3 CH2 CH2 COOH. So this is correct option. When reactant X is treated with a suitable reagent, products Y and Z are formed. Infrared spectra of X, Y and Z are shown. Okay, when reactant X is treated with a suitable reagent, products Y and Z are formed. Infrared, okay. So sharp long peak of C double bond O is absent, and OH peak is also absent. It means it does not contain aldehyde, ketones, alcohols, ester and carboxylic acid. So Y and Z. YZ sharp peak C double bond O is present but OH peak is absent. And in product Z, 15 to 1700, this is CO peak, sorry, this is CO peak, this is also absent, and C double bond O peak is also absent, but this is 1500 to 7000, 1500 to 16, just C double bond O is present, must be ketone. Now C double bond O peak is present, sharp peak at 15 to 1700, so that is of C double bond O according to the data booklet, and from 25 to 3000 is the OH peak, so it means okay. Y is propanone, can be propanone, but 2,3-dimethyl pentoene, 2,3-dimethyl pentoene. X could be 1, 2, 3, 4, 5. Two, 3, CH3 and CH3. Okay, 2ene. So this is not possible to form propanone and butanone. Butanone Z is the carboxylic acid, so this is incorrect, incorrect, incorrect. So 2-methyl pentoene. X peak is 2-methyl pentoene. Yes, this is C double bond C peak. Could be according to the data 3000. Alkene peak is present. So 2-methyl pentoene. Two-methyl CH3 and 2ene. So Y is propanone. Yes, C double bond O is present, OH peak is absent, so it can be propanone, and it is also correct. And Z peak is this, so this is B option is correct. Ethanoic acid, propanoic acid, pentoene can be, but this is correct option. Now come section B, question number 31. A sample of 17.15 mole of HI. So here can be solved. So this is 17.15 mole of HI is in dynamic equilibrium, 2.27 mole of H2 and 2.84 mole of I2, 4 mole of I2 in a volume of 1 meter cube at 764 Kelvin and 141 kilopascal. P is equal to nRT and P is equal to nRT over V. So look at this. Hydrogen iodide is Kc and two equilibrium constant Kc and Kp can be calculated for this mixture. Which statement about the equilibrium for this mixtures are correct? Neither Kc and Kp has any unit cell. This is correct option. This is correct option because Kp and Kc has no unit. So this is partial pressure of HI. So this is Kc value is 45.6. Concentration mole over 1000 1 meter cube. This is mole is in dynamic equilibrium with 2.27 mole of and mole of I2 in a volume of 1 meter cube. So this is Kp 17.14 into 8.314. P is equal to nRT and P is equal to nRT over V. And this is equal to 17.15 mole into 8.34 into 764 is equal to this value, and pH2 2.27 into 8.314 into 7 this value, and partial pressure of iodine is this value. So Kp can be calculated by using this, which is equal to 45.6. So Kp is equal to 45.6. So Kp 1 meter cube 17.15 mole is in dynamic equilibrium with 2.27 mole of H2 and 2.84 mole of I2 in a volume of 1 meter cube. So this is Kc is equal to 17.15 square H2 and I2. 17 point H2 mole is over 1 meter cube. Two point 27 2.84. This is equal to 45.6. So this option is also correct and this is incorrect. So it means if 1 and 2 option, this is B option is correct. Now next question is Energy cycle for the combustion of methane is shown. Which expression can be used to calculate the energy change delta Hc? So delta Hc is the formation of carbon dioxide, combustion of carbon dioxide water. So the energy cycle would be delta Hc can be calculated. So this is the cycle. So this is formation of CH4 and this is combustion of, so this could be delta Hc is equal to delta HF plus delta CH4 and delta HC CH4. So this is incorrect. Delta HC solid, yes, delta, this is also correct, delta HC carbon plus 2 moles of delta HC H2. So this is also correct. So carbon monoxide is changes into carbon dioxide. This is incorrect. It's not valid. So these two, 1 and 2 are correct. 32. This is now next is the 33. 33. Many gases do not obey the general gas equation at high pressure. Why is this? At high pressures the molecules have more energy. More high pressure does not increase the energy. So it is incorrect. At high pressure the volume of the molecule is larger proportion of the total volume. Yes, volume, because volume of the molecule is negligible, but at high pressure volume of molecule is large proportion of the total volume. This is correct. At higher pressure the molecule experience greater intermolecular, because molecules come closer to each other and they have experience greater intermolecular forces. So this is also incorrect. So if 2 and 3 are correct, then the option is C. Which species can accept a lone pair of electrons to form a coordinative covalent bonds? So BF3, so this structure is like this. So it is deficient of octets, so it accepts the lone pair of electrons. So this is incorrect. H positive is also deficient of electron, so it also accept a pair of lone pair of electron. CH3 is also deficient, so it can also accept the pair of electron. So this is also incorrect. So if 1, 2, 3 are correct, then the option is A. 35. A sample containing X mole of Al2Cl6 dissolved in water to give solution W. So you know that if we know that Al2Cl6 when dissolved, Al3 positive and Cl negative ions, and this could be formed Al complex ions H2O6 3 positive is formed. In order to precipitate all of the aluminum as its hydroxide, Y mole of sodium hydroxide are required. So when sodium hydroxide are required, so it is also converted into Al H2O OH, and this is 2 plus and plus hydrogen ion. More of the alkali is added to redissolve the precipitate, giving solution Z. Which statement are correct? So excess redissolves Al2Cl6 plus sodium hydroxide to form AlOH thrice plus sodium chloride 6 and 2 aluminium. So the initial pH of solution W is below 7 because hydrogen ion is produced in this reaction, so that's why the initial pH of the solution W is below 7. So this is correct. Y is equal to 3x. What is Y? In order to precipitate all the aluminum as its hydroxide, Y mole of sodium hydroxide are required. Y moles of, so 6 moles of hydroxide, this is 6, Y is equal to 6, and Y moles of sodium hydroxide required. Most of the alkali to redissolve the solution precipitate and giving solution Z. Which statement? So Y could be 6 and 3x, x moles of, so x could be 1 mole. So this is also incorrect. If 2 is incorrect, then 3 is also incorrect because there is no options for having 1 and 3. So Z contain x mole of aluminum. Z contain, what is Z? Giving solution aluminum hydroxide contains not x mole of aluminum. This is aluminum hydroxide. This is also incorrect. So D is correct option if 1 is correct only. Nitrogen dioxide gas is produced when petrol is burned in car engines. Which acids are made in the atmosphere as a result of this release of nitrogen dioxide into the air? Which nitrogen dioxide gas is produced when petrol is burned in car engines? So when SO2 react with H2O, H2SO3 is formed. But which acids are made in the atmosphere as a result of nitrogen dioxide? This acid is not formed as a result of this release of nitrogen dioxide. So NO2 plus SO2 to form H2 to form NSO3 and NO, and SO3 then react with water to form sulfuric acid H2SO4. So this is correct. And nitrogen dioxide when react with water to form HNO3 plus HNO2. So this is also correct. So if 2 and 3 are correct, then option is C. In which reaction is the major product formed by a nucleophilic substitution reaction? Bromoethane plus potassium cyanide in ethanol. In which reaction is the major product formed by a nucleophilic substitution? Bromoethane CH3 CH2 Br and plus potassium cyanide in ethanol, so it can be CH3 CH2 CN. So this is nucleophilic substitution. This is the major product, so this option is correct. Bromoethane plus ammonia in the ethanol under pressure. CH3 CH2 Br, and this is when react with ammonia in ethanol under pressure, ethylamine is formed, CH3. This is also nucleophilic substitution, and only one major product is formed, NH2. This is the major product. Bromoethane plus hot concentrated sodium hydroxide in ethanol. Major product formed, sodium, hot concentrated sodium hydroxide, nucleophilic substitution. So this is elimination reaction, and elimination, hot concentrated sodium hydroxide in ethanol forming alkene. So CH3 CH2 Br to form CH2 CH2. So this is incorrect. One or two are correct. The option is B. An excess P react with Q in the presence of concentrated sulfuric acid. Q and P. Concentrated sulfuric acid. An excess of P reacts with Q in the presence of concentrated sulfuric acid. Effervescence is seen when a piece of sodium is added to R. P react with Q in the presence of concentrated sulfuric to R. This is P. So effervescence is seen when a piece of sodium is added to pure R. What could be Q? Yes. This is when react with this is CH3 C double bond OH plus CH3 OH CH2 COH. Yes, effervescence is seen when it reacts with hydrogen gas is produced, when it both react with carboxylic acid, over here ester is formed, and when sodium metal is placed, hydrogen gas is produced. So this is OH CH3 CH2 OH plus CH3 CH3 OH, CH2 C double bond O and OH. So H and OH, water is formed, and this OH when react with sodium, effervescence of this could be formed ONA, and hydrogen gas, effervescence of gas can be seen, and the rest of the molecule form ester, like CH3 CCH3 and ONA, CH2 C double bond O and CH2 CH3. This is the product of this reaction. So effervescence of hydrogen gas, this is ketone, so no effervescence when it reacts with, and no, it does not react with the alcohol nor carboxylic acid. This is incorrect. This is correct, this is correct. The option is B. 39. Two carbonyl compounds have the molecular formula C3H6O. Which reagent give different observation? Two carbonyl compounds. This could be aldehyde and ketones. CH3, CH2, CHO, and this is CH3, C double bond O and CH3. Acidified potassium magnate, different observation. Aqueous potassium magnate, it is oxidized into carboxylic acid 1, CH3 CH2 C double bond OH, and for this the observation would be purple to colorless, but cannot oxidize further, so no change. Failing reagent, aldehyde gives positive test with the failing reagent, but ketone does not show any change, so this is also correct. Alkaline aqueous iodine, so alkaline aqueous iodine gives yellow precipitate with ketones because CH3 is formed, CH3 directly linked with the C double bond O, so it gives the yellow precipitate, but aldehyde no change with the aldehyde, so this is also gives two different observations, so this is also correct. So if 1, 2, 3 are correct, then option is A. An organic compound T does not phase when sodium carbonate is added to it. Compound T contains 27.6% by mass of oxygen. Does not phase when, so propanol does not phase when it does not react with sodium carbonate and cannot produce any gas. So it contain, propanol contain CH3 CH3 CH2 CHO. So 1, 2, 3, 12 3s are 36, plus 3, 2, 5 and 1 6, or plus 16. So this is equal to 58. Now calculate the percentage composition of oxygen. 1, 16 into 1 divided by 58 into hundreds. This is equal to 27.6. So this is correct. And ethyl ethanoate, ethyl number 2 is ethyl butanoate, CH3 CH2 CH2 COO C2H5. 2, 3, 4, 5, 6. 12 6 are 72 plus 3 to 5 to 7 or 5 to 7 and 2 9 or 3 12. 12 hydrogen and 32 oxygen. So this is equal to 2 to 4 or to 6 3 6 3 1 4 and 7 11. So this is equal to 116. So oxygen is 32 divided by 16 into 100. This is also equal to 27.6%. So this is also a correct option. So 3-methyl propanoic acid. So this can produce when react with sodium carbonate, carbon dioxide plus water along with salt is formed. Sodium pentanoate salt is formed, and this carbon dioxide, it can fizz, so it is incorrect. So 1 and 2 options are correct, so option is B. So this is all about. If you like this video, please subscribe this channel, and if you have any confusion, you can ask in comment box.